Quantum teleportation is a phenomenon in quantum mechanics that allows the transfer of quantum information from one location to another, without physical transfer of particles. It does not involve moving matter instantaneously through space, as often depicted in science fiction, but rather it involves the transfer of the quantum state of a particle. The concept of quantum teleportation was first proposed by Charles Bennett, Gilles Brassard, Claude Crépeau, Richard Jozsa, Asher Perez, and William K. Wouters in 1993. It relies on a phenomenon known as entanglement, and involves a process that generally follows these steps. Initial preparation. Two entangled particles are created and shared between two parties, often referred to as Alice and Bob. These particles are typically in a state of quantum entanglement, which means that their properties are correlated in a way that the state of one particle is dependent on the state of the other, regardless of the distance between them. Bell measurement. Alice performs a joint measurement, known as a Bell measurement, on the particle she wants to teleport and her entangled particle. This measurement extracts certain information about the quantum state of the particle. Classical communication. Alice communicates the results of her measurement to Bob using classical communication channels. This communication provides Bob with the necessary information to apply a specific quantum operation on his entangled particle. Quantum operation. Based on the information received from Alice, Bob performs a specific quantum operation on his entangled particle. This operation transforms his particle into an exact replica of the original particle's quantum state. Final state. As a result of the quantum operation, Bob's entangled particle now carries the quantum state of the original particle, effectively teleporting the information from Alice's particle to Bob's particle. It's important to note that quantum teleportation doesn't involve the actual transfer of matter or energy. Instead, it transfers the quantum information contained in the state of a particle. This process is governed by the principles of quantum mechanics and relies on the unique properties of quantum entanglement. Quantum teleportation has been experimentally demonstrated with various types of particles, including photons and atoms, and it has potential applications in quantum communication, quantum computing, and secure data transmission. However, it's worth mentioning that practical quantum teleportation over long distances or with larger and more complex systems remains a challenge due to the fragile nature of quantum states and the technical difficulties involved in maintaining entanglement over extended distances.